on Monday the 21st of February. Before we get going with the applications, I've just got a picture here. It was actually taken I think 3 years ago, and it's at Hamilton Gardens. And what we're seeing here is a picture taken of a sundial. So you can see the gnomon, which is the pole, pointy pole in the background. We're looking towards the north, and you can see the shadow has actually moved off the marked area. So I think the picture was taken just before 6 p.m. between Christmas and New Year. But so we can't use it to tell time at this time of day because the shadow's off the marked area. But what I wanted to bring up are the blue figure of 8 lines there. I'll just zoom in a bit so you can see them a bit better. So I've got a couple of questions about this. First of all, and you can reply in the chat anytime up to the end, we'll have a look at it. And the first thing is, what are these blue figure of 8 markings and tiles on the ground called? And the second question I have is, you notice that there's more than one of them. And you notice the one, if you can see the mouse pointer, just to the left of that spot there, the spot between the line between the gnomon and the spot is the north-south line. So my question is, why is this one in the position it is and not running north-south? So feel free to have a think about that and answer in the chat. So that's all I wanted to do with that picture. It's really worth visit to Hamilton Gardens if you're interested. They've got different style gardens from all around the world, and including local Maori gardens. So really interesting to see. They put a lot of work into it, and the development is ongoing. But I thought the sundial was particularly interesting. It illustrates a lot of astronomical information. Okay, so the first application I'm going to show here is called Stellarium, and it's defaulting to showing the current time. So you can see we've just got a twilight background. So at this time of year, it's not dark for a wee while. So we'll just bump the time forward a bit. So we're now after dark. So we're looking towards the south, and I've got all of the indicators and lines and labels turned off. So Delirium is trying to render the night sky approximately what you would see. We can zoom in and out. You can also change effects of light pollution and so on, which will show more or less stars. So we're just going to I'll zoom out a little bit, take a wander around the sky, and I'm sure you can recognize some of the iconic constellations and asterisms. So there is some good scientific data even at this level. What Stellarium tries to do is it renders the star colors approximately as you might see them with the naked eye. It's not really exact, but if we choose the star here, you notice it's quite a slightly reddish or orangish looking star. So this is, of course, Alpha Orionis, Betelgeuse, and you notice the text comes up in that same color. So what it's using to figure out what color to show the stars is this color index, B minus V, and it says 1.52. So the higher that number, the more reddish the star will look. And what this refers to is the UBV photometric system of filters. So B means blue, V is visual, which is a sort of blue-green, and there's another one called U, which is for ultraviolet. The problem is on the Earth's surface, ultraviolet actually is quite strongly attenuated as soon as you get out of the visual band. So it's not 100% useful as an actual ultraviolet filter, but it's still a long used standard filter system. There are many others that are used for this purpose. The Gaia satellite has its own system of filters. So yeah, you have to, whenever you see these photometric type measurements, you have to be aware of which filter set is being used. We look at Rigel and you notice the bluish look to it, and you see here the color index is minus 0.03. It's quite interesting. We can go to the Southern Cross, choose the star here, which is Beta Crucis, and you notice that the blue index is even more blue than Rigel, minus 0.25. So this is the most blue star that you can see with the unaided eye, and in fact one of the bluest stars in the sky. I chose this to look at because we can zoom in. Hang on, I'll just center it for you. And we'll select the star again and keep zooming in. Actually, it runs off center. That's interesting. And keep going. And you'll notice in a telescopic field, there's this red star here. And this one has got a color index of 3.5. So it's quite interesting. Within a very small field of view, you've got one of the bluest stars and one of the reddest stars. This one is actually DY Crucis, a carbon star. Anyway, that's a bit about the color of the stars that Stellarium is showing us there. Zoom out a bit and we see the jewel box star cluster, which is near Mimosa or Beta Crucis. And so this is one of the easiest star hopping things you can find. If you're familiar, you can locate the Southern Cross. I'm sure most of you can do that. If not, we'll zoom out a bit further so we can see it. These are the 4 Southern Cross stars: Ga Crux, Eta Crucis, Alpha Crucis. Sorry, that's actually the reddish one there is actually the 5th star that's shown on the Australian flag, but not on our flag for some reason. Delta Crucis, quite a blue looking star there. And back to Mimosa. So you can see that the jewel box cluster or Kappa Crucis is quite close in the sky. So easy to find via star hopping as long as you can find Beta Crucis. If you're having trouble with that, you've got the 2 pointers, Alpha Centauri, also called Rigel Centaurus, and Beta Centaurus or Hadar, which acts as a pointer towards the Southern Cross, and in particular Ga Crux. So that's a real simple star hop you can do using a bit of basic knowledge of the night sky. Find the jewel box cluster. A slightly more tricky one, we can zoom in a bit and you notice the short arm of the cross. If we jump about the same distance roughly to here, there's this little asterism, and I'll center it and zoom in on it. And it sort of looks like a flattened kite. If we turn deep sky objects on, this is how you can locate the blue planetary nebula. It's quite small in the sky, and you need probably a fairly decent magnification. So it's quite a bright, high surface brightness object. So you can crank the magnification right up to 200 or more if you've got a sufficient aperture. So this is a method of star hopping, finding blue planetary nebula. If you can see, you'll easily see these 4 stars in your finder scope. So that's an example. We can go back to Orion and easily recognize the Orion star cluster, or it's actually a constellation, but it's also an asterism. There's another asterism within Orion called the Pot, and you can see the pot forming. This is the base of the pot itself, also called Orion's belt. And then at the handle, we have what is actually not a star, but the Messier 42 Great Nebula in Orion. So if we zoom in on there, you can find M42, or the Great Orion Nebula. If you're searching for it in your telescope, just locate the 3 stars of the Orion's belt, and then you'll see the Orion Nebula, or M42, will appear as a fuzzy star in the handle of the Pot asterism. We'll zoom out a bit, and we'll find that we have Canis Major, which is also called the Great Dog. This one here is Sirius, or Alpha Canis Major. And within the constellation of the Great Dog, it's kind of rendered upside down for us in the southern hemisphere. So if you can imagine, that's the tail of the dog, the hind legs, the front legs, and then within the body of the dog, you should be easily able to find the M41. It's quite a large cluster, and that will be a way of finding it. You just find Sirius based on the location of Orion. Can't miss Sirius, it's the brightest star in the night sky. And find M41. And you can then branch out from there, somewhat fainter star clusters, and this is actually in the constellation of Puppis, but you can find M46 and 47, which are quite close together. And you can use the star hopping technique again to find those. Another one, we come over to this asterism here, which is the sometimes called the Gem cluster. But in this part of you can see the outline of the Milky Way heading down towards the Southern Cross from Orion. But we have here a asterism that's called the False Cross. If you can see that being marked out here, and if you go along the long axis of the False Cross, go a bit further, you see this quite bright cluster called here the Sprinter cluster. I've more commonly heard it referred to as the Diamond cluster. If we zoom in, I'll just center on it and zoom in, you'll see that it's a rich cluster of a lot of stars, quite good in a small telescope or binoculars even. And you see that this is quite bright, just a bit brighter than 4th magnitude. The magnitude for clusters refers to the cluster as a whole, not to the individual stars. If we pick an individual star, you can see that the magnitude is actually quite a bit fainter, 6th or 7th magnitude. This one is the 5th magnitude, so that's probably the brightest cluster in the star, this particular star cluster. Okay, we'll do another one. And this time what we're going to do, it's probably a bit earlier, it'll be a bit better later in the time of year, or wait out to later at night. If you look at the 2 pointers, follow that towards the Southern Cross, but instead of continuing on, you take a left turn past the star here, and we about the same angular separation, we find the Omega Centauri star cluster. So I'll just center on that, and we'll zoom in. As you see, it's still fairly low in the sky, even when I've jumped forward an hour or so. But later in the year or later at night, it'll be climbing higher in the sky. And this is the richest globular cluster in the night sky in either hemisphere. And it's known now that it isn't a normal globular star cluster. It's believed to be the core of a dwarf galaxy that has been captured by the Milky Way. The rest of the galaxy is being stripped away, and the central core of the galaxy remains, and to us appears as a globular cluster, well over 1 million stars. If you follow that line further past Omega Centauri, if you've got a good dark sight, it's actually quite hard to see this galaxy in the city, but as you just carry on at that line about the same, not quite as far, you find Centaurus A, which is a interesting radio galaxy. You can see the dark band across it. It is visible with a relatively small telescope, but unfortunately the city lights wash it out, so or the full moon especially, if you can get out to a dark sky site, this galaxy is quite an easy one to find. Okay, I'm going to go back to the northeast side of the sky. We had Alpha Canis Major up here, Sirius. You can find these two, this fairly bright star Procyon here, and it forms the constellation of the Little Dog. So you've got Alpha Canis Major, Beta Canis Major here. You then follow this down towards the horizon. You can find this cluster in a small telescope or binoculars called the Beehive cluster. It's actually in the constellation of Cancer, the Crab. So this is quite interesting, quite a nice cluster. Covers a fairly wide area of the sky, and yeah, worthwhile having a look at on a small telescope or binoculars. So I'll just show you one more star hopping thing. I'm going to change the date. Let's go a couple of months in advance. Actually, I'll go a wee bit. Oh, no, we don't need to go any further than that. You can see this arrangement here is the constellation Corvus the Crow. And let's zoom in. Okay. If you follow the line down from the Crow towards the horizon, you can see the star that I've picked on there, Eta Corvus, and we'll come down a bit further, and you just sort of drift down past these stars here. You can see these three stars forming a flattened triangle. So this is actually quite easily visible in binoculars or a finder scope, but they're still quite faint in those small telescopes or finder. But then you treat this as an arrow and come down and then find these three stars, which are in a straight line, and they're showing the magnitude about 7th magnitude, 7th, the two fainter ones. We'll zoom in a bit more so it lets us pick it out. So we've got another, the brighter one is 7th magnitude, and the two fainter ones 8th magnitude. But you can see that they act as a guide to finding the Sombrero galaxy Messier 104, which you can see easily in a 6 or 8 inch telescope, provided you've got a dark sight. You won't see it as you see it in the pictures, but you can certainly see the streak of light that forms the galaxy. Okay, that's probably enough for star hopping. I think you get the idea. You start off with things that you can easily see with the native eye. Use your star mapping program like Stellarium or others. Cell phone apps are quite good, and I'll demonstrate one of those in a little while. But before we get on to that, I want to show some of the other things we can do here. Just with Stellarium. So I already showed you we can turn off deep sky objects. We've got Messier objects, Caldwell objects, new general catalogue objects, index catalogue, and you can see there's a heap of other ones that you can turn on that it has loaded up. We've got sky markings. Some of them we can turn on at the window at the bottom. For example, I can put on constellation lines. So that's basically showing, I think by default it's the HA ray lines. We can turn those off. We can turn on the constellation labels, and we can also show the constellation boundaries. So if you're trying to work out where the constellations are and you're not sure, some of them are quite confusing. They're basically lines, they're made up of lines of constant right ascension and declination. So the declination lines basically go north-south, and the right ascension lines go east-west. And you can see, though, they're not simple shapes. Sometimes, depending on the constellation, they can have these steps. And these were made up back in the early 19th century, where the IAU basically came up with these standard constellation boundaries, and they're based on traditional Western constellations, and they added in a bunch of the southern constellations that were known to mariners and used for navigational purposes. So that's how those came about. Stellarium also has a whole lot of traditional star lore from different parts of the world. You can go into your sky viewing options, select star lore, and we can see the local, oh, actually it's still showing deep sky, so I probably have to turn that off. And you're starting to see, I don't know how comprehensive it is. It looks as though it is not actually. They've just got a few things. I know that they do stars. So if we go to solar system objects, I'm not sure whether we can get it to turn labels and markers on. Oh yeah, because we've got the local star lore, it's now coming up with the local star names. So Atuhahi would be Alpha Carina or Canopus. So you can play around with all those things and learn the night sky in different cultures. So we'll go back to our Western one for the time being. Now we've also turning on all the star labels. We can show the equatorial grid. This is basically showing you the positions and lines of right ascension and declination. We can confuse things further, putting on the alt-azimuth grid, and you can see things start getting quite messy, so you probably don't want to have both grids on at once. We can make sure our planet labels are on. Another really useful thing is these, actually, if you're not sure where something is in the sky, it's got a really simple sky function, search function. So for example, if I didn't know where Sirius was in the sky, I can just type in Sirius and click find. And there we go, it's centered on Sirius. So it's a free application. It's got a huge amount of functionality in it. It can actually drive your telescope. We don't use it at the Society Observatory at Cumia or the Stardome with the research scope or the Zeiss, because for that it's a more professional software called the SkyX they use. And the reason that particular one is used because the robotic mounts they use are also either supplied by Software Bisque or using Software Bisque retrofitted hardware, and so for best compatibility they use the SkyX program. Nothing to stop you using that as well, but it's not a free application. So this here is quite interesting. This little tool in Stellarium, you can get it to plot the positions of various solar system objects, and we can select anything you like basically there, and you can get it to generate a table of positions over time. You can also get it to plot that on the map, like we go from date. Actually, Comet Leonard is known about there because we had that in the sky recently. It's gone now, but we could, for example, go back in time, plot it from the beginning of January, and probably solar day would be a bit silly, but let's go every 5 solar days and to the current date, and we can calculate it. So that will tell you the position of that comet, how it evolved over that time. And we can actually, we've got it to show the markers. So if we, let's see whether it's done that or not. Oh, it has. You can see that because it's got the position place it in is getting lower in the sky now. The markers are nearly set, but it's okay for illustration. If I come back to earlier time, you can see that it's showing you the plot of the path of the comet over time. And you can do that for planets as well, show their position in the sky over a period of time. I won't worry about that right now, but I'll show you another thing in here. You want to go into the configuration window, plugins, and the solar system editor. What this is used for is loading comet information. So if you hear about a comet and you can't find it in Stellarium or it doesn't know about it, what you need to do is to go into the solar system editor and you select this button, import elements, select comets, and the main ones are already built in, but you can, if any site on the internet that has the comet data in MPC format, you can select it here. And there's 3 there. I think these ones are built in. You can go to the Minor Planet Center's list of observable comets or the MCORB site. You basically set which one you want and just click Get Orbital Elements, and it's basically gone away and downloaded them. You can either select specific ones, or we can go Mark All, Add Objects, and then as soon as you do that, they are known to Stellarium. And this is worthwhile doing even for comets it already knows about, because comet orbits, especially if they're in a phase where they're outgassing, their orbits can get a bit unpredictable. So if you want accurate information, it pays to go back and get an update. And then any changes to the comet orbit will be reflected or known to Stellarium. So there's a heck of a lot of other things in here that I won't get into, but do get hold of the application. Download it from the official stellarium.org site, because you never know with malware and what have you. So go to stellarium.org and obtain it from links off there. It's a multi-platform OS, but the mobile version of it you have to get from the App Store, but I believe it's not. Stellarium on the App Store isn't free, but there are lots of other free mobile apps. What I'm going to do next is just quickly show another free desktop application called SkyChart. I'm just starting the program. Okay. Now this one isn't as pretty as Stellarium. For example, when I drag things around, all the markers disappear. Whereas if you do that in Stellarium, everything gets rendered as you're dragging it around. So it's a little bit more sophisticated in that sense. But the reason you might want to use this program is that if you want to print star charts for any reason, to have an actual hard copy, I wouldn't advise it. You can print Stellarium, but it will print with a dark background, which is horrible for wasting ink or laser toner. For printing, this program will print charts that have the sky background as white. So it's a lot more sensible for printing sky charts. The other thing about it is that Stellarium, the catalogues that it's using for objects are its own, and I found there's some inaccuracies. Like I showed DY Crucis before, and when you zoom in, just picking it out off the map, it shows the correct star, but you notice that it didn't have the name DY Crucis. If you went back to the search for DY Crucis, it does know it, but the position is slightly wrong. And I think that's an error in the way they've built their star catalogue data. What this program does, if I show you in catalogues, it came up on the other screen, you can basically add a whole bunch of catalogues. And if you go to the SkyChart website, they have them there set up in a form that Cart2Seal can read. It has all the common ones, the Tycho ones from the US Naval Observatory, a whole host of different catalogues. So you can choose the one you want to use for your project. Some of them will have over 1 billion stars in them, so they're quite large downloads. They have the Gaia satellite there, not all in one chunk. It's so big you have to load down parts of it depending on which part of the sky you're interested in. If you want to basically explore the Gaia data, you can do it with this program. And again, only download it from the official site. Okay, what I'm going to try and attempt now is to get it to show my mobile phone on my laptop screen, so you can see it on this presentation. So give me a couple of minutes to set that up. So the program I'm going to show here is called Sky Safari, and it isn't a free program. I really like it because one of the things it does is includes a lot of information about the objects, written information. So I've just started up Sky Safari, and then I've just got to find a screen sharing app that I use. Okay. Just connecting my computer. Okay, so tell it to accept the connection. So now what I should be able to do, hopefully everyone can see that, I'm using a program called AirDroid. So I'll start mirroring. Start now, and hopefully it should prompt me on the phone. Is this going to work for me? I'll just try again. Sometimes I have trouble getting this to let me do it. Okay, it's worked. Phew. Okay, here we go. I'll just try to bring that up as maximum size I can show you. So let's select now. Oops, hang on. And we'll go forward. Okay, I'll just zoom out a little bit so we can see what's going on. So what I've done now, I've put the app into what's called compass mode. So you can see it jittering around. So at the moment it's pointing at the ground. So it's using the accelerometer and the sensors in the phone to figure out where it's pointing. So this is quite a cool thing. You can actually aim it at a star in the sky, look at the screen, and you can see on the phone, it will tell you what you're looking at. So that's a really useful feature if you're outside. I'm just going to turn that off so it goes into the normal mode. Since I see the Eskimo Nebula there, let's go into, actually I'll search again. It's a planetary nebula. See what it finds. Okay, so you see here, this is the information I was talking about. Tells you information about the object, and if we carry on, tells you about the discovery by William Herschel. John Herschel, also his son, also observed it. So, and there's a Hubble Space Telescope image. So all of the deep sky objects in here come with a usually with quite a good description telling you what you're looking at. We can also do tonight's best. So for example, select 47 Tucanae, we get a picture. Tells you all about it. We want to see the object, so we want to go to it, and we can zoom in. So I think this is the plus version of the app. There are different levels depending on how much you pay, how much you get. If you don't want to pay, there are lots of free ones. I'm sure if you want to mention in the chat what your favourites are for other people to have a play with. Another interesting thing with this program, we can see if it works. Oh, you've got, for example, I didn't show you in Stellarium, you can change to night view so that the screen is a bit more friendly to your night vision. We can do that, so it changes everything to red. We can have an observing planner in here. You can actually type in your observations about, set up an observing list of the things you're planning to look at on an observing session. You can record notes in here. This can also control a telescope. In fact, I remember one time they played a joke on somebody with a mount where they had a Stellarium, not Stellarium, sorry, Sky Safari controlling a mount from a mobile phone, and they were telling somebody that this mount was actually voice controlled. So they got him to try it and say Saturn. Somebody type in Saturn on the phone and the mount would dutifully go to Saturn. But they fessed up as to what was going on eventually, but I thought that was quite amusing. You can see we can connect to the scope if we have a Wi-Fi connection to the scope. Another thing we can do, just go out of that. I actually got some various things there you can select. I'll just go out of it. What was the other thing I was going to show? Go back to do another tonight's best. Well, let's select a planet. I'll go out of that. Just wanted to demonstrate something. Oops, Jupiter's just about in solar conjunction now, but I noticed the keyboard is actually partly in the red and partly not. Get the thing to get rid of the keyboard. Oh, it's possibly because it's still got this connect thing here. To get rid of that. Try again. I'll do Saturn actually as in the dawn sky, but what I was going to show is this, instead of centering it in the map, let's orbit and we'll go out and fly out to Saturn. So Saturn is actually in the dawn sky at the moment, but I'll just turn night mode off. Whoops, didn't want to do that. So yeah, that's quite a cool feature. I think it allows you to zoom out to stars as well. So let's exit out of orbit. Oops, didn't want to do that. Sorry about that. Go back to Stellarium. How do you exit out of this thing? Live sky? No, maybe later. To figure out how to quit out of. That's just. Oh, it's the Earth one that gets out of it. Yeah. Okay, so we've gone home, or we're going home. Thanks for Steve for that. Okay, and we'll go compass mode off. Okay, just go back to the sky. Let's try the Large Magellanic Cloud. I don't know if it'll do this or not. Why isn't it bringing me the? Oh, maybe you have to. Whoops. You can see I don't use my phone apps very often. Let's get out of this. I want to get rid of that. No. Trying to get this thing off the screen. I'll kill it the hard way. Sorry about that. Oops. Let me try this again. I wanted to see if it would go to a deep sky object. I don't know if I've ever tried this before. Let's try 47 Tucanae and orbit and see. Oh, yeah. So at least some of the deep sky objects it'll let us orbit. Although it doesn't, I guess some of that grey stuff there is the Milky Way, or maybe that's the Small Magellanic Cloud, actually, I'm not sure. Anyway, I'm sure that's the Milky Way. We're flying back to Earth. So you can have a bit of fun with it. Okay, I'm sure there are plenty of these apps you can have a go at, and try out these programs, and I'm sure they'll be very helpful learning your way around the night sky. So do we have any questions before we finish?
Thanks, Bill. That was super interesting. So first of all, coming back to where you started, which was your picture of Hamilton Gardens, Mitchell Clark was up first, answering the question that they were analemma.
Yep, that's quite correct.
Closely followed by
each one is
Mike.
showing it for a different clock time of day.
So that was there's a bit of discussion between Mike and Niven actually on what the multiple analemma and the offset means. So probably the first one that would account for the shift would be Niven, who said the offset of the analemma to the side of where the solar noon line was due to Hamilton's longitude compared to the time zone.
That's absolutely correct, because New Zealand's time zone standard time is set to 12 hours from Universal Time, or UT, we used to call GMT. But if you look at where that actually corresponds to, that's actually to the east of New Zealand. So at that time of day, at noon clock time, 12 hours, or in summer, we add another hour for daylight saving, but we're just talking about standard time here. So the 12 hours plus UT, or 12 hours plus Greenwich Mean Time, it's actually, the sun hasn't actually crossed the meridian in New Zealand, and particularly not in Hamilton. It's still to the east. So that's why the analemma, which is the clock noon, is actually slightly to the west of the north-south line, because the sun at that time of day is still to the east. Did anyone have an explanation of what the analemma actually is, or what causes it?
No, nobody suggested that. I'm not sure you asked that specifically.
No, I didn't. I just wondered if anyone listening in might wonder what on earth it is. So basically what it's doing is looking at where that solar shadow would be on the sundial at a particular hour of day as you go through the year. For example, if you were looking at clock noon, the one that's just to the left of the north-south line, and you plot on the ground the position of the solar shadow at clock noon as you go through the year, you end up with that shape forming on the ground. Is called an analemma, and it's caused by a couple of things. The fact that obviously the sun is higher in the sky in the summer and lower in the winter, so the parts of the shadow closer to the gnomon are obviously when you're close to the summer solstice, and in the winter solstice the shadow is going to be further from the base of the gnomon. But the reason it isn't a straight line, and the reason is because the Earth's orbit is actually not circular. The Earth's orbit is an ellipse, and so it travels faster and slower at different times of year, and that combined with the fact that the Earth's axis is tilted, meaning the sun's position in the sky changes as the seasons pass. The combination forms the analemma. There's some astrophotographers who, way back in the film day, took a picture of the sun at 10 o'clock. It's lots of different days during the year, and then superimposed that on they obviously have to do really short filtered exposures of the sun, and then they would, on the same film, then take a general background photo of the sky with a terrestrial object. I think there's a Greek guy who's famous for doing this with analemma for different time of day, and you actually then see the sun plotting out the analemma on the sky rather than the shadow on the ground. Quite interesting effect. So anything else, Steve?
Yep, a couple more. There's a comment from Mike who says that Stellarium on the iPad is a paid application and it's $24.99. I might just add to that. You demonstrated Sky Safari Plus there. Simulation Curriculum have just brought out the latest version, Sky Safari Plus 7. And it's actually on special, I think, till the end of the month. I know the Apple version's about $17, but that's an option for people to save some money on the latest version of that. Another couple of things.
There'll be an upgrade cost as well from 6 to 7, is there?
Yeah, so it's you essentially rebuy it. The new one's got a slightly refreshed interface. You probably don't need it, but I tend to buy the latest versions.
I should use it more often because I don't use the cell phone apps enough. So anyway.
We had a comment from Sidewalk Astronomy Netherlands who said at least 12 of the southern constellations are Dutch.
Yeah, that's probably true because the first explorers that came south were Dutch. Not the first, Magellan obviously, but many of the following ones were Dutch explorers. Abel Tasman is a well-known example, who was the first European to come across the shores of New Zealand and Australia after the indigenous people. So yeah, that would be quite right. Many of those early constellations would have been Dutch navigators that gave the original names for those.
Yeah, I posted up a Wikipedia article in the chat. So the 12 constellations would be Apis, Chameleon, Dorado, Grus, Hydrus, Indus, Musca, Pavo, Phoenix, Triangulum Australe, Tucana, and Volans. if anybody
Right,
wants
a number of the other southern constellations are named after astronomical instruments, like or the horologium, the clock, and telescopian. I think there's yeah, a number like that.
Question from Anne.
Sextans is another one.
Question from
Oh,
Anne
sorry.
is there any way to recalibrate Sky Safari's compass feature? It never seems to line up correctly on my phone.
That could be to do with I'm not exactly sure how it does it, but I know that if you have a phone compass, they have a calibration procedure you go through to calibrate the compass. I'm not sure whether that would help with Sky Safari. Do you know the answer to that, Steve?
I think it's possibly variable on different devices. So it's I know that there's an AR mode and you can adjust the image on the AR mode. So maybe give the AR mode a try.
Okay.
And the final question.
Oh, sorry, go on. They have a tilt tip meter measure that can figure out the angle the phone is tilted at. And they also have a compass built into them, and obviously they know their location via GPS, and they have an accelerometer, and I know definitely the compass app tells you to go through a calibration process. I don't know at all whether that would help with, if you calibrate a compass, whether it helps apps like Stellarium or Sky Safari. Anyway, just a thought.
So Mike has just commented, Android and iOS will let you calibrate the compass. Google will give you more info on that. Yeah,
I don't know if that helps with Sky Safari though. But it may be worth trying it.
Final question, unless anybody else wants to get in there quickly, is from David, and David wants to know, what are the best objects to look at in the night sky with 7x50 binoculars?
Oh, okay. Well, that's obviously any of the brighter star clusters are good in binoculars, like the one I was talking about before called the diamond cluster is quite a good binocular object. The Pleiades, the southern Pleiades as well, or Matariki if you like for the northern one. The southern Pleiades, I didn't mention that, but that's near one of the stars in the Diamond Cross, if you look that up. Is it IC 2602? Can you remember, Steve, is the catalogue number?
Can't remember off the top of my head.
Yeah, something like that. But if you look up Southern Pleiades, you should find it. That's it's got similar dimensions as the Matariki, so it's quite a good object to look at in binoculars. You can see the jewel box cluster, but it'll be very small. That's probably better on a telescope. The beehive cluster I mentioned. And if you have a look on for a cluster called the Wishing Well cluster, that's quite good in binoculars.
Southern Pleiades is IC 2602. I just looked up on Sky Safari. So
okay, I did.
You're right with that.
Correct. Okay. Yeah. So and you can actually see the Great Nebula and Orion with binoculars. It's not going to look all that spectacular, but you can definitely see that it's a non-stellar object. You can see a little. It's quite small, but you can definitely see the nebula in 7x50s or 10x50s. I don't know, somebody might want to suggest some other good ones to look at.
And that is it for the questions. Thanks, Bill. Super interesting as usual.
Okay, next week, I'm not sure whether we're going to be able to stream it live or not. It's going to be an in-person lecture with social distancing, and it's the last of the series of Beatrice Hill Tinsley lectures. It's going to be held at AUT in Lecture Theatre WA 220, We have to work out whether we're going to be able to stream it live. It's turned out there's a couple of issues that have cropped up with that, and I'll talk to Steve about it later. Anyway, thanks for joining in, everyone.
Thanks, Bill. Thanks, everyone.